Hello friends, welcome to lecture series on multivariable calculus. In the last lecture we have seen that what do you mean by limits for several variable functions. We have seen that if we write limit xy tending to x naught y naught fxy is equals to L, this means if this limit exists and is equal to L, it means for every epsilon greater than 0 there exists a corresponding delta greater than 0 such that mod of fxy minus L is less than epsilon whenever 0 less than under root x minus x naught whole square plus y minus y naught whole square is less than delta. So, we have seen that whatever epsilon may be, no matter how small, how large it may be, there will always exist a corresponding delta greater than 0 such that this inequality hold. That means for every epsilon there will exist a delta such that a disk centered at x naught y naught of radius delta, all those xy lying in that disk will always, the image of all those x lying in that disk will be contained in L minus epsilon to L plus epsilon, and that is the geometric interpretation of this definition. Now, let us discuss some important properties of limits. The first property is limit xy tend to x naught y naught fxy if exist is always unique. Okay. Next is to find out the value of the limit. The another method is convert Cartesian coordinate into polar coordinate system. That means if we substitute x minus x naught equal to r cos theta, y minus y naught equal to r sin theta, where r square is equal to x minus x naught whole square plus y minus y naught whole square, and tan theta is equal to y minus y naught upon x minus x naught. That can easily be obtained if you divide the second expression y minus y naught is equal to r cos theta and x minus x naught equal to r sin theta, then we obtain tan theta is equal to y minus y naught upon x minus x naught. The definition of the limit can be expressed in this way. So, basically if we are having limit xy tending to x naught y naught, which we have just explained you, fxy equal to L, then to find out this limit, the another method is convert this Cartesian coordinate into polar coordinate system. So, how can we do that? You simply take x minus x naught as r cos theta, y minus y naught as r sin theta, where if you square and add, it is simply r square is equal to x minus x naught whole square plus y minus y naught whole square, and tan theta is equal to y minus y naught upon x minus x naught. Okay. Now, as r tending to 0, whatever theta may be, x will tend to x naught and y will tend to y naught, that is xy will tend to x naught y naught. Okay. So, that means there are two ways, either you convert xy tend to x naught y naught to xy tend to 0 0 and then you can convert this into polar coordinate system, or the another way out is you simply take x minus x naught as r cos theta and y minus y naught as r sin theta. Okay. So, now this limit will convert to limit r tending to 0, because as r tend to 0, x will tend to x naught, y will tend to y naught, that is xy will tend to x naught y naught. Okay. This will be f of r cos theta, r sin theta, and the limit will be same L. So, how we can define this in delta epsilon now? So, to show the existence of this limit, again we will use the concept of delta epsilon, that is for every epsilon greater than 0 there will exist a corresponding delta greater than 0 such that it is mod r less than delta implies mod of r cos theta r sin theta minus L less than epsilon for all theta, for all r and theta. This must hold for all r and theta. Okay. So any Cartesian coordinate, if you have a limit to find out in any Cartesian, so either you can proceed in the Cartesian way only, or you can convert this into polar coordinate system to find out the limit. Now, for example, we have this problem, changing into polar coordinate system, show that limit of this is equal to 0. Now, let us try this problem. So, we were discussing about that how we can show existence of a limit by delta epsilon definition. So, let us consider this example, that is limit x y tending to 0 0 x cube upon x square plus y square, and the limit is 0. Okay. Now, let us try to prove this, that this limit is 0. So, we have two ways to show this. The first way is convert x and y into polar coordinate system, okay. And the second way is you can proceed by the usual Cartesian method, okay. So, let us first try to prove it by converting this into polar coordinate system. So, we will suppose that x equal to r cos theta and y is equal to r sin theta. Now, as x y both are tending to 0 0, so it will be possible only when r will tend to 0. Okay. So, this limit will convert into limit r tending to 0, x is r cos theta. So, it is r cube cos cube theta. Now, r square cos square plus r square sin square is r square, because cos square plus sin square theta is 1. So, this is equals to limit r tending to 0, it is r cos cube theta, and this is clearly 0 for any theta. You can, if you take any theta, if limit r is tending to 0, this will always tend to 0. Now, to show this, that this is equal to 0, we will again use delta epsilon definition. Okay. So, let epsilon greater than 0 be given. Okay. So, it is mod r cos cube theta minus 0, which is equals to mod r cos cube theta, which is equals to mod r into mod cos cube theta, which is less than equals to mod r into 1, because mod cos theta is always less than equal to 1. So, and this is less than delta. So, if we choose delta less than equals to epsilon, then mod of r cos cube theta minus 0 will be less than epsilon whenever 0 less than mod r less than delta. So, hence we have shown the existence of such delta for which this inequality hold. Hence, we can say that this limit exists and is equal to 0. Okay. Now, the same can also be proved by the usual delta epsilon definition without converting this into polar coordinate. If we want to prove this result without using polar coordinate, then also we can do that. Without using polar coordinate also we can prove this limit. Let epsilon greater than 0 be given. We have to show that mod of x cube upon x square plus y square minus 0 is less than epsilon whenever 0 less than under root x minus 0 whole square plus y minus 0 whole square is less than delta. This we have to prove. We have to prove the existence of such delta. Okay. Now, we take this inequality mod x cube upon x square plus y square minus 0. this is equals to mod of x into x square upon x square plus y square. This is further equals to mod of x into mod of x square upon x square plus y square. Now x square is always less than equals to x square plus y square. Okay. So x square upon x square plus y square is always less than equal to 1, and it is also non-negative quantity. So we can say that it is less than equals to mod x into 1. Okay. And this mod x, now you can use the other definition of limit, or mod x cube upon x square plus y square, or if you want to use same, you can use same also. So we can use this definition here. So if we take this is less than delta, so choose delta equal to epsilon, then we have done. So we can prove this existence of this limit without using polar also, but if we use polar coordinate system, then we can get the result easily. Okay. Other properties of limit is two path test for the non-existence of a limit. If from two different paths as xy approaches to x naught y naught, the function fxy has different limits, then this implies limit does not exist. Okay. So what does it mean? Let us see. Now we are having x axis, y axis. We have a point x naught y naught. Okay. This point is basically x naught y naught. We take a neighborhood of this point. This point is x naught y naught. Okay. Now if we take any neighborhood of x naught y naught, okay, all those xy lying in this region, there are infinite paths by which this xy can approach to x naught y naught. It may be a straight line, it may be a parabolic curve, it may be some other curve. Okay. There may be infinite paths. Okay. Now existence of limit means if we follow any path from xy to x naught y naught, it must be path independent. Path independent means whatever path we follow from xy to x naught y naught, the value of the limit will always be unique. If the value of the limit, if you are saying that limit xy tending to x naught y naught fxy is L. Okay. This means if we take a neighborhood of x naught y naught and we are taking any x in this neighborhood, there are infinite paths by which xy can approach to x naught y naught. It must be path independent. That means whatever path we follow from xy to x naught y naught, the value of this limit is always L, will always remain the same, because limit is unique. Limit is always unique if it exists. That means if from two different paths value of the limit are not same, value of the double limit, we are calling it double limit, if the value of double limit are not same, this means limit does not exist, because if limit exists, this means it must be path independent. So to illustrate this, let us discuss few examples. Okay. The first example is limit xy tending to x naught y naught xy upon x square plus y square. Now okay, 0 0, it is 0 0. Now from xy to 0 0, there are infinite paths. Okay, we can follow any path. Suppose this is origin, okay, and this is any xy. This is any xy. So we can move along x axis, we can move along y axis, we can move along y equal to x, we can move along y equal to 2x, we can move along y equal to x square, they are infinite paths. Okay. So, let us move along x axis or y equal to 0. Now, if we move along y equal to 0, from this point to this point, from this path we are following, if you follow this path, then what is the limit of this expression? There will limit extend to 0, y equal to 0, okay, and xy upon x square plus y square, and it is when you substitute x equal to 0, when you substitute y equal to 0, so the value is 0. Okay. Now let us move along say y axis or x equal to 0. Now, if you move along x equal to 0, it is limit y tending to 0, xy upon x square plus y square and x equal to 0. When you substitute x equal to 0 here, this is 0. Now, from these two paths value are same. What does it mean? From if from two different paths value of the double limit are same, it means the double limit, that is this limit, may or may not exist, because these are only two paths and they are infinite paths from xy to 0 0. They are infinite paths. Okay. And if from two paths value are same, it does not mean that the value exists, value double limit exists and is equal to 0, because there may be some other path from which the value of this limit may be different. For example, if you take say y equal to x, if you move along y equal to x, then limit x into 0, you substitute y equal to x, it is x square upon x square plus x square, which is limit x into 0, x square upon 2x square, which is 1 by 2. Now, from this path value is 0, from this path value is 0, and from some other path value is 1 by 2. So, values are not same, values are different. This means this limit does not exist. So, we can simply say this implies limit xy tending to 0 0, xy upon x square plus y square does not exist. Okay. Why it does not exist? Because from two different paths values are different. Okay. Now, the other way out to show that limit does not exist is, you take a path, general path. Okay. You take a general path, you move along say y equals to mx. If you move along y equal to mx, this means it is limit, you substitute y equal to mx, it is x into mx upon x square plus mx whole square, and x is tending to 0. Remember this, that this path must pass through x naught y naught, must pass here, x naught y naught is 0 0. So, this path must pass through x 0 0. Okay. Whatever path we are choosing, it must pass through this point. Now, this is equals to limit x into 0, it is mx square upon x square times 1 plus m square, x square cancel out and it is m upon 1 plus m square. Now, this value, the limit, this value comes out to be dependent on m. You take different values of m, say you take m equal to 1, this value is 1 by 2. You take m equal to 2, then this value is 2 upon 5. So, for different values of m, the value of the limit are different. This means limit does not exist, because now it is path dependent. We take different paths, values are different, it is path dependent. However, it must, if limit exists, it must be path independent. So, it depends on m. This implies limit xy tending to 0 0 xy upon x square plus y square does not exist. So basically to show that limit does not exist, the double limit does not exist, we have two ways. The first way is you take two different paths and try to show that from two different paths value of the limit are different. The other way out is you try to show that it is path dependent. You take some arbitrary path like y equal to mx or y equal to kx square or something and try to show that it depends on m or k. Okay. In this way we can show that limit does not exist. Say we have second example, it is limit xy tending to 0 0. The problem is x cube y upon, okay. Now if we move along say y equal to 0, if you move along y equal to 0, then this value when you substitute y equal to 0, then this is clearly 0, okay, because when you substitute y equal to 0 here, this is 0. Now you move along say y equal to x cube along this curve. If you move along y equal to x cube, then this is nothing but limit x tending to 0 x cube into x cube upon x to the power 6 plus it is x to the power 6, which is equal to limit x tending to 0 x to the power 6 upon, which is 1 by 2. So from one path value is 0 and from other path value is 1 by 2, this means this limit does not exist. Now the next example is limit x y z tending to 0 0 0. It is x y z x square plus it is y to the power 4 plus z to the power 4. Now we have to find a path such that it comes out to a path dependent to show that this limit does not exist. Okay. So we can choose some path, say we can take, let x is equals to some k t square, say y equal to say t and z equal to t, where t is some parameter. Okay. Basically in 3D we are taking this curve. Okay. Now when you substitute this, it is limit x is kt square, y is t and z is t, and it is k square t raised to power 4 plus t raised to power 4 plus t raised to power 4 and limit t tend to 0, because as x y z all are tend to 0, this will happen only when t with t tending to 0. Okay. And this is equals to limit t tending to 0, it is k into t raised to power 4 upon k square plus 2. So this will be equal to k upon k square plus 2, that is depends on k. It depends on k. This means this limit does not exist. Okay. So in this way we can show that double limit does not exist. Now if you take, say if you take 4 5 paths and the value of the limit always come out to be same, then again this does not guarantee that the limit exists, because there may be some other path by which the value of the limit comes out to be different. If we have to show the existence of a limit, we have only option is delta epsilon definition. We have to show the existence of a limit using delta epsilon definition only. To show that the limit does not exist, we can use this concept. We can use two different paths and try to show the value of limit comes out to be different, or we can try to show that it is path dependent. Now we will talk about iterated limits and double limit. Now what does it mean? You see that double limit is this thing, this is xy tending to x naught y naught fxy. Suppose it exists and equal to L, okay, and we have it is called double limit, also called double limit, okay. And other things are iterated limit. Iterated limit means limit x tend to x naught, limit y tend to y naught fxy, or limit y tend to y naught, limit x tend to x naught fxy. These are called iterated limits. Okay. Now if you take x naught y naught here, okay, and you take a neighborhood of this point, center at x naught y naught, you take any xy in this disk. This means you first take y tend to y naught keeping x constant, and then you take x tend to x naught. So first you are taking y tend to y naught. This is x naught y naught, okay. First you are taking y tend to y naught means this thing, okay, y tending to y naught, okay. This is some point xy, okay, y tending to y naught. Now this point is x naught y naught, okay. Now here first x tend to x naught and then y tend to y naught. So we come to this point, okay. So this is y tend to y naught and then x tend to x naught. So we come to this point, okay. Okay. So these are basically two different paths. One path is this, another path is this, okay. Now if this limit exists and is equal to L, then the iterated limit value of the iterated limit is also equal to L, provided limit y tending to y naught fxy and limit x into x naught fxy exist. If this condition hold, then only we can say that if double limit exists, then iterated limit also exists and equal to L. So basically if this is equal to L, then this implies, then this condition implies, if this is equal to L, then this condition implies that these are also equal and is equal to L, provided this inside limit exists. Because if this limit exists, then these are basically two paths, okay. If this limit exists, then these are basically two paths, and if this is equal to L, this means it is path independent. If it is path independent, then from these two paths also the value will be same, value will be L. Now if we see the converse part, if this exists and suppose this and this are equal to L, then these are only two paths, okay. If this and this limit exist, then these are only two paths, and from these two paths if limit comes out to be L, then this double limit may or may not exist, because basically these iterated limit, if this limit exists, are only two paths, okay. So, let us understand this by giving some examples. You see, suppose you take this. It is x plus y upon x minus y. Suppose you want to compute this limit, x minus y should not equal to 0. Now if you find this limit x tending to 0, limit y tending to 0, x plus y upon x minus y. If you find this limit, this is this iterated limit, then this is limit x tending to 0. You simply substitute, you simply tend y tend to 0, then it is x plus 0 upon x minus 0, and when you take x tend to 0, then this is 1. Okay. Now you take the other iterated limit, it is limit y tend to 0, it is 0 plus y upon 0 minus y, and when you take y tend to 0, it is minus 1. So, iterated limit exist and are not equal. Okay. You see that this limit and this limit exist. This limit is 1 and this limit is minus 1. This and this limit exist. Okay, and iterated limit are not same. This means, this implies limit x y tend to 0 0, x plus y upon x minus y, this does not exist. Okay, because if this inside limit exists, then these iterated limit are simply two paths, and from the two different paths values are different. This means this limit, double limit, does not exist. Okay. Now see another example. It is limit x y tending to 0 0, it is x square y square upon, it is again x square y square plus x minus y whole square. Okay. Now, the problem is find a double limit and the iterated limit if they exist. The provided denominator is not equal to 0. Now, first you find the double limits. Okay. So, you take limit y tending to 0, limit x tending to 0 f x y, which is x square y square upon x square y square plus x minus y whole square. Now, when you put when you take x tend to 0 here in this expression, so this will tend to 0, then this is simply equal to 0. Okay, one can easily see that when you take x tend to 0 in this expression, so numerator is 0, so the value is 0. Now, the other iterated limit is limit x tend to 0 suppose, and limit y tend to 0 x square y square upon x square y square plus x minus y whole square. Now, when you take y tend to 0, again numerator is 0, so this value is again 0. Now, these inside limits exist and the iterated limits are same. What does it mean? What can we say about double limit? From here we can say that double limit may or may not exist, because these are only two paths. It may be possible from some other path where your double limit comes out to be different from this limit, from this value. Say if you take a path, say you take a path along, say take a path y equal to x. If you take a path y equal to x here, so we will obtain limit x tend to 0 x square upon x to the power 4 plus 0, which is 1. From this path we are getting value 1, and from other paths we are getting a value 0. This means limit does not exist, because there are two different paths from which value of the limits are different. this means the path dependent, then this implies this limit does not exist. Okay. So, hence we can easily show that whether a limit exists or it does not exist. To show the existence, we have to go only through delta epsilon definition. To show that the limit does not exist, we have to show that from two different paths values of the limit are different. Okay. So, thank you very much.